Down here we have a graph of what I propose is the answer to this question. I've labeled it as big F instead of little f. And that means if we find big F and take the derivative of it, we will get little f, which is what we started with. 4 times square root of 1 minus x squared. And over here to the right, I have the graph of the derivative of f of x, big F on Desmos. And I have the original problem, 4 times the square root of 1 minus x squared, and they're the same. So this kind of proves that this answer is correct. And by the way, I show here that f of 1/2 is negative 10. Question is, how do we get to this guy right here? Well, when you see the square root of 1 minus a minus x squared or x squared minus a squared, that tends to tell you that we might use trig substitution to eliminate the radical. So when you use trig substitution, you want to use either the sine, the tangent, or the secant function. And thinking of a little right triangle, you want to use the trig function that in such a way that the radical doesn't appear in the trig function of theta, and you don't want any variables in the denominator. So if you label a little right triangle like this, here's theta. This 1 is sort of like the hypotenuse squared minus a leg squared. The square root of that will give you the other leg. And now I can see that the sine of theta is opposite over hypotenuse. And dx will equal the derivative of sine theta, which is cosine theta d theta. By the way, I make note of the fact here that if sine of theta equals x, theta equals the inverse sine of x. We'll use that later. But now, what happens when I do the trig substitution? Well, this x squared, x is sine theta, so x squared is sine squared theta. But 1 minus sine squared is cosine squared, and the square root of cosine squared is cosine theta. So when we go from here to here, we're using trig substitution. And I've already figured out down here that the square root is replaced by cosine theta. The dx is replaced by cosine theta d theta. So I'm actually finding the antiderivative of cosine squared theta d theta. Now that's an integral that usually appears in integral tables. You can prove that using integration by parts. I'm not going to go into that, but probably in the back of your calculus textbook, you can find the antiderivative for cosine squared. It looks like this right here. You might also find a reduction formula for the cosine to the nth power. But anyway, if I replace sine of 2 theta with 2 sine theta cosine theta, that's a double angle identity, and then distribute this 4, I get 2 theta plus 4 times 1/4 is 1, so I just get 2 sine theta cosine theta. Now, how can I get rid of the thetas? I got to go back to down in here. Theta is the inverse sine of x, so that's where this comes from, 2 theta. Then I have a 2 sine of theta. Well, the sine of theta is x over 1. You can just look at your little right triangle. The sine of theta is opposite over hypotenuse. The cosine of theta is the square root of 1 minus x squared over 1. And then finally, I introduced the constant of integration right here, plus c. How do I find out the value of plus c? Well, we're told that when x is 1/2, that f is negative 10. Big F is negative 10. So the inverse sine of 1/2 is pi over 6, or 30 degrees. 2 times pi over 6 is pi over 3. That's where this pi over 3 comes from right here. The square root of, this is the square root of 3/4, which is the square root of 3 over 2. That's where this comes from. And what I did was take this those two terms to the right side of the equal sign and factor out a minus. Okay, so there you go. Hope that helped. And if you have any questions, post a comment.